works in a far longer time frame than we do, because she's a geologist. She has been the curator of Canada's geological treasures for some time. And every time we brought a fossil home from Strange Place, we'd call her up and say, "We got this thing. A, are we allowed to bring it into Canada? And B, can you please tell us what it is?" And that has been a very interesting and productive program. Now, she has really carried the rock for geology in Canada. She's been out there making speeches as the head curator of the collection. And I'll give you one last observation. She told me one time, said she was often asked to go and talk to school groups. And she comes into this one school group and says, "Well, we don't believe in evolution, so don't mention evolution. Give the talk on dinosaurs, but don't mention evolution." And she's going to tell you how she did that. So I'm happy to give you Jean for her nice presentation.
Thank you, Ted. I'm not sure whether or not I should explain how I did that. I spoke rather sternly to the mother of these children who came in, and I basically said, "Your tax dollars pays for my salary, and you asked for this presentation, and you will get the presentation that I am going to give you, because that is what my job is. You can take it or leave it." Thank you for the opportunity to present really and truly one of my pet projects, if you will. Geology is one of those topics that when it comes to environmental sustainability or anything else, where you're going to live, what you're going to do, very, very, very few people actually take geology into account when it comes to making some major decisions. So the presentation I'm doing today, Madeline asked me to do this, 6 or 8 months ago when I agreed to do it. She said, "Can you tell us where we should live when when things go bad?" And I said, "Well, yeah, I could do that, but I really don't have recommendations. But what I'm going to do is I'm going to, I hope, tweak your interest in little things as we flit across the country and look at different things and how you should actually approach decisions about where you might want to live and why. And what are some of the geological things that might pertain to the decision that you're going to be making." So what I've got here is a presentation where it's sort of divided up into two parts. First part will be talking about national issues that may be of concern to you, something that you might be interested. And then at the end, I'm going to show you some of the local things that you might want to look at. There was a group of posters that were done by the Geological Association of Canada and many geologists across the country looking at geological things in local areas. So I am going to make a presentation, or a short presentation, on the Geoscape Ottawa. These things are called geoscapes. So the local example will be focusing on the Ottawa. We'll be talking about some of the things that many of you have heard about but probably don't really understand particularly well, and we'll go from there.
Just right.
So, first of all, national. This lovely map is the geological map of Canada. And what I want you to, you can't really see any detail, but what I want you to focus on is this big pink blob right in the middle. This area here. You would know this as the Precambrian Shield. And this particular rock is, to a geologist, these rocks are the central craton. They are the mother of North America. And these rocks range in age from the oldest rocks on Earth are found up near Yellowknife. It's called the Acasta gneiss. And they range in age from that to about 1 billion years ago. So we've got rocks in here that are about 3.5 billion years old, 3.8, almost 4 billion years old, down to things that are about 1 billion years old. Okay, so think these numbers, as Ted said, I think in a different time scale. So this is the time scale that when it comes to geology, that's what you have to look at. So the Precambrian Shield, what do you guys remember? You think about it and you kind of go, I don't know, it's just the shield. But it's the oldest rocks on Earth. And that, what I want you to focus on here is for the Quebec and Ontario, the things that we've got here on the corners, the pink stuff is basically gneisses and granite. gneiss, G-N-E-I-S-S. And the green ones are greenstones. Wonderful, right? Geologists like simple things, you know? And the yellow is metasediments. So the things to look about. Granites and gneisses are igneous rocks. If I can remind you guys, igneous are rocks that cool from a liquid rock, magmas, blah, 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 blah. Greenstones are metamorphosed igneous rocks. And metasediments are metamorphosed sedimentary rocks. Now, to a geologist, hard rocks are igneous and metamorphic rocks. So the whole of the shield are the hardest rocks that we've got around. Very difficult to break down, very difficult to erode, etc. These are generalities, but just to give you an idea of what these rocks look like, I'm going to show you a couple pictures. This one is a gneiss. You guys may recognize some of this kind of rock in that the group of 7 made them very famous. These are, you find them everywhere from Georgian Bay all the way up north. Do you see a lot of plants here? No? Okay. These are granites, okay? And the granites are the pink things in the middle. They're granite dikes, and they are actually done up into a host mafic rock, also igneous rocks. So the forest, I want you to see at the very top of that picture, there is a little forest that's growing in the back. They're pretty small trees. And when we have igneous and metamorphic rocks, especially in the Canadian Shield, that has really only been exposed for about 10,000 years or less after the last glaciation, there has not been sufficient time for soils to develop. And if there are soils, they're very thin. So you don't get very much growing there. What you will get will be forests, boreal forests, and depending on how far north you go, you are going to be getting some really small bits and pieces of trees, not really small trees. You can have a tree this big that is going to be 50 years old, right? They just don't grow very well. The soils are very thin. So you're looking at, in the Canadian Shield, you have very thin, very poor soils that are very poor for agriculture. So one of the things I hear regularly from people is that, you know, with climate change, we'll just move north. Where's your agricultural belts in Canada? You cannot move north in Quebec or Ontario, the biggest parts of our country, the big central part of our country, because they don't have soils. You can grow things there so long as you have good hydroponics, but you certainly cannot grow them on the soils that we've got because they're too thin and they're too poor. So just a little aside to look at. The next thing to look at here is the boreal forest cover, how it corresponds to the Canadian Shield. So the light color is in the very far north. You can actually see that that's actually shield rock, but there is not enough forest cover, and what's going to be there, it's too cold. You're not going to get any forests at all. It's basically the tundra. Very blank, very hard rock. The darker color is the boreal forest all the way along. So here in the areas of Western Canada and up into the territories, you're looking at boreal forest where it's not shield rock. But I'd like to point out that there is a huge swath of mountains that go right through here. The Rocky Mountains go all the way up into the Yukon Territory. So the reason we've got boreal forests there is because we have mountains, not necessarily because it's some other kind. So the rest of this, the medium color, is where we have overlap of the boreal forest and the Canadian Shield. So one of the things, those of you who have been following the idea of mountain pine beetle, for example, and the issues that are associated with the mountain pine beetle that has everybody panicking out west in particular, is that the mountain pine beetle, it isn't cold enough anymore for the mountain pine beetle to be killed over winter. So what happens is we end up getting the mountain pine beetle coming across the mountains, and we are starting to get massive fires in places like northern Alberta. Whoa, has anybody heard what's going on in Alberta these days? How about British Columbia? Exactly the same sorts of things. So with climate change, we are going to get a lot more drying, we're going to get a lot more severe weather, a lot more lightning, and the risk to the boreal forest in Canada is massive. And one of the things that you may or may not have heard when the Canadian Department of Environment gave out their report, I think it was about 2 or 3 months ago, about Canada and climate change and how we're going to respond to it. For years, Canadians were saying, well, our boreal forests are carbon sinks. Not anymore. They are going up in flames so much that we are actually contributing carbon dioxide to the atmosphere these days. So it is no longer, oh, well, we have these forests, we're okay. No, it's not. So this is one of the things to look at, and the overlap, the shield, is one of the controlling factors as to where the boreal forest actually locates in Canada. Did you guys ever know that? No, exactly. Who cares, right? All right, here's another thing to look at. One of the issues that people talk about every so often is permafrost, permanently frozen ground. Now this is a map, really busy map if you want to look at it, but it's basically the permafrost map of Canada. Was done by Natural Resources Canada. They have a huge group. They have a group of people who study the permafrost in Canada and the implications of that for the nation. What I want you to focus on is the the purple stuff up here is the continuous permafrost. That is ground that is frozen all the time. Simple definition. Blue is extensive continuous, meaning there's permafrost through most of it, and it is permanently frozen, but it is not continuous all the way across. There can be spots where it is not. Green is the sporadic, discontinuous, and then yellow is isolated bits and pieces. So the yellow parts, again, notice here, the yellow parts, we do get permafrost in the mountains, but one of the things when I spoke to the permafrost people, this map was done about 15 years ago, the permafrost and the discontinuous to the continuous is moving north. This line is moving north, and we are starting to get melting of the permafrost. And you are hearing there are huge issues associated with the melting of the permafrost. So, we'll go into this. One of the issues is the fact that when you melt the permafrost, you're going to get a lot of problems and movement of material, because frozen stuff, ice, doesn't move as much as something that's sort of like a wet mud. Okay? So you're going to get shifting of structures and so on. You are going to get a lot of erosion, especially in the Arctic, where you have the permafrost that's right there, and you're starting to get slumping as it melts. It melts at the areas where it's exposed, and that's what you're going to get. You're going to get a lot of melting. Notice the lovely clumps of grass that have come down here, and so you're going to get huge problems there. You are also going to have infrastructure. Do you guys remember the, well, no, it's not quite the same thing, but similar. The rail tracks here, they closed off the railroad going into Churchill because of problems with the rail lines. Now, technically, that is not in part of the permafrost area, and it's not the same as shield rock because it's in a slightly different area, but you are going to get that kind of warping. So this is, I don't know that I'd want to ride a train. Something like that, you know, really and truly. Okay, and the housing. You get the risk of landslides when you start getting melting of the permafrost is much higher than it was when it was solid. And in this particular case, you're getting a mud flow that took out houses, but you're also going to get all the houses and infrastructure that have been deliberately built on stilts. For example, the northern pipelines that are up in the Arctic and some of the houses in the Arctic, you're going to get shifting of those houses because of the melting of the permafrost underneath the structures. So it's a huge problem. And what a lot of people haven't thought about is the fact that initially when I saw this picture, I actually thought that it was staged, but it's not. This is a Russian veterinarian in a hazmat suit studying these reindeer and the reindeer herder, because in Russia about 10-15 years ago there was a reindeer carcass that came out of the permafrost. It was about 10,000 years old, and it had anthrax, and it killed one of the herders. So we are looking at, one of the things about melting permafrost is the release of many toxins. You're looking at, one of the things, I hadn't realized this until I started to look at things, the northern permafrost in Canada is one of the biggest reservoirs of mercury that has been pulled in and sequestered, and once that starts melting, the mercury is going to be released into the environment. You have arsenic, you have the PCBs that were put up there for permanent storage by NORAD and all of the people there. They were thinking it was safe. We are going to be releasing a lot of potential environmental hazards with the melting of the permafrost. In addition to that, there is a lot of things like peat, I call it, organic material that was frozen into the permafrost. It's going to start melting. And when it starts melting, you're going to start getting decomposition of the organic material, which releases carbon dioxide into the atmosphere. And this other little piece over here on the side, right here, that lovely piece, is a piece of ice. And it's burning. It is burning because this is a methane hydrate. And in the Arctic and all through the sediment or the basins in the Arctic oceans and as far south as Hawaii, depending on how deep you go, methane hydrates are sequestered in a frozen layer at the base of the oceans and so on. And in the Arctic, we have a huge reservoir of methane. And these things, when they come out, you can actually burn it because the methane is enclosed in an ice crystal structure. So that once the ice melts, you've got the methane coming out. And, okay, need I say more? And the one that really got me when I, again, was looking at things is, I don't know how many of you knew, about 20 years ago, the world's agricultural departments got together and they put together a seed bank of all the major crops that we have in the world. And they put the germ seeds of all of these major crops into a seed bank in Svalbard in northern Norway, thinking that if something happened, catastrophically happened, we would have the seeds that we could go back to. They had a melt and a flood in the seed bank last year. So there is the potential destruction of one of the major reserves that we might have in the world. You scared yet? Are you interested yet? Do you care? Okay. This is another one that's kind of interesting. The watersheds. This is a sensitivity map that was done with respect to the watersheds of Canada. And the sensitivity is not necessarily more water or less water, it's just how sensitive it is to climate change. So the darker ones in the west, you're probably going to get more drought on the eastern side of the Rockies or the mountains, and to the west you're actually going to get a lot more water. So the watersheds are really going to have problems with respect to how they're going to deal with this. It's not too bad through the central part, but notice the parts where we're living right now. Okay, we're going to get a lot more water here, and we are going to have issues in eastern Canada out into Halifax, or out into the Maritimes and up into Newfoundland. So that is going to be a major issue that people may wish to contend with and think about. But here's another one. Now these are pretty small pictures, but I want to point out landslides are going to be a problem into the future. Now, up until this point, okay, this kind of a landslide that we're looking at here is one that was, somewhere in the Rockies, coming into the CN-CP rail lines. What happened was we had a lot of rain coming down and snow melt and so on, and it took out the rail line. Okay, that happens out west. The rails are shut down, I would think, at least once every couple of years, if not more often than that, just because of landslides that take out the rail beds. Now this one is a very famous landslide. It's called the Frank Slide. This is from a great distance, and this was in, I think it was 1905, and they were actually tunneling or digging for coal up on Turtle Mountain, and one of the major things about Western Canada is you have a geologic fault where you have, well, technically you have older rock being overlain by younger rock being overlain by younger rocks, which is unusual. Younger overlain by older. And that fault line was what gave way. The coal beds that they were looking for are in the younger rocks, and they were down in the other younger part. And the older rocks were limestones, and when they started to tunnel out the coal in the younger rocks, they disturbed the fault line, and the whole of Turtle Mountain came down and buried the town of Frank down here. When Dave and I went through there 20 years ago, the rocks that are at the base here are the size of Volkswagens. Those are the small ones. So this was a huge, it killed over 100 people sleeping in their beds that night. Now this last one over here is one that you'll hear a lot more about, this particular landslide that happened in 1993 on the South Nation River just outside of Ottawa. It's called the Lemieux landslide. And this is a landslide that happens in almost completely flat land. Okay, and I'll explain to you how that happens as well. So, okay, we're going on to the next flower. I've flitted from rock types to permafrost to landslides. Okay, earthquakes. Nationally, in Canada, if you wanted to move someplace, the really big issue that you have to think about, this is not climate change related, but out on the west coast, yeah, you are looking at a tectonically active seismic zone in Canada. And the risk is very high. In eastern Canada, you can see this line that actually goes up, big surprise, it goes up the St. Lawrence River. Now, one of the things to a geologist, it's sort of second nature. Water flows at a place where there's going to be a discontinuity in geologic material. If you've got something that's homogeneous, it's hard to break. But if you've got a place where two different kinds of rocks meet each other, you have a discontinuity, and it makes it a little easier because one is harder than the other and things can go there. So almost every major river in Canada has a major geologic discontinuity in it. And the St. Lawrence River is one where we have the Precambrian shield on this side, and we have much younger rock on the other. So the Logan Fault is what it's called, named after Sir William Logan, who was the founder of the Geological Survey of Canada, is the line that runs down the St. Lawrence River. So it's just, these faults can sometimes reactivate depending on geologic circumstances. And we do get earthquakes in Ottawa, but nothing like the kinds of earthquakes that we get out in the west. I'm going to start talking a little bit about some of the local things. Here is a list of the various geoscapes that were produced by interested groups about, we really focused on doing these things about 15, 20 years ago. And you can see there's a long list, and I would strongly recommend, unfortunately on here it doesn't show up, but the place where you can find this information is on a website called earthsciencescanada.gc, and also look for Geoscience Education Network, Canadian Geoscience Education Network, CGEN, which is part of that website. All of the geoscapes, and you can also just put in that word in your search engine, and it will take you directly to that site. It'll hot link to these geoscapes. And the geoscapes have been produced for each individual city or area that you're looking at, and they're all following pretty much the same idea as what we've got for the Ottawa geoscape. It's a huge poster, probably about the size of this screen. And basically the central part of the poster shows you the geographic area they're talking about. And each of the panels that you have around that central part are talking about a specific thing of interest in that particular area. So for the Ottawa area, there are many things, and I will go through the ones that might be of greatest interest to people. But if you're really, really interested in volcanoes, you might want to look at the Vancouver website. If you're really interested in finding about water quality and how that kind of thing can happen, take a look at the Toronto one, because the Oak Ridges Moraine is one of the biggest issues about water quality in the Toronto area. So look at the individual ones and see, because everywhere across the country there are different aspects of geology that are important to that local region. So one of the really neat things about the Ottawa area is that we have 3 different rock types of 3 different time zones that really control the different physiography of the Ottawa area. So everybody knows we've got the Gatineau Hills. This is the area north of Ottawa, and it is basically the 1 billion year old igneous and metamorphic rocks that make the Gatineau Hills. It is the ancient core of the continent, just the very edge of it. And again, this is shield rock. So you're looking at the shield there. So that's, within about a 10-kilometer radius of Parliament Hill, this is what you're going to be looking at. We jump forward from 1 billion years to 500 million years, and you have the gray and sort of dull-looking rocks that you see around Hogsback, underneath Parliament Hill. As you're driving out to Canada, you'll see all these really nice sandstones that are very nicely piled up. Those are all rocks of the early Paleozoic, 520 to 440 million years old. I can just throw these numbers out, no problem. But think about that for a minute. This is a really, really, really long time ago. And at that time, Ottawa was on the edge of the ancient continent of North America. It was south of the equator and rotated 90 degrees from where North America is situated now. So you're looking at North America was south of the equator. Ottawa was a coral reef environment, nearshore coral reef. And over the last 500 million years, Ottawa has come up and rotated up 90 degrees from where it was located 500 million years ago. Thank you, plate tectonics. Okay, so that's what we're looking at here. And then, as you go out to the east end of the city, you're going to be looking at the flat-lying rocks that are associated with the Champlain Sea deposits. Now, this is one of the things when I'm talking to students and people about the geology of the Ottawa area. 1 billion, 500 million, and 10,000. Okay. Basically, you're looking at, in geologic time, a speck. The last 10,000 years is nothing, geologically speaking. But what we have are these Champlain Sea deposits, which are tending to be, the Champlain Sea formed as the glaciers were melting. 15,000 years ago, we had about 2 kilometers of ice over top of what is now Parliament Hill. And actually about 20,000 years ago was their peak. And by about 12,000 years, the ice had melted and receded away from Ottawa, but we had a huge inundation of fresh water from the melting of the glaciers. In addition to that, as you remove 2 kilometers of ice, the ground, when you have that kind of weight on top of it, the ground depresses. So 2 kilometers of ice melted away. It takes a while for the ground to rebound. It's not quite like a foam mattress that does it in seconds. And it took a while, so the Atlantic Ocean flowed up into the St. Lawrence and the Ottawa valleys, and we had basically a marine environment here. So in the Ottawa area, we have beluga whale fossils, we have Arctic aspect clams and oysters that we see in the rocks. We see a whole bunch of different kinds of fish that are now only found in the cold waters in northern Canada. So it is exactly the same species, but we are in a completely different part of the world. That was only 10,000 years ago. So there was some change from that. So generally speaking, the rock types are important, but that's why Ottawa is interesting. But this, the Champlain Sea, is something that really, really, really is important with respect to where you might want to buy or live in Ottawa. Because the Champlain Sea deposits, this is the one of the major components of the Champlain Sea deposits, are these things called the clay, or you might know it as the lit de clay. Now, lit de clay is an unconsolidated, meaning it's not a rock. It is unconsolidated clay that, because it was in a marine environment, there are salt crystals that have been packed into that clay. So once it gets formed, it looks really solid because the salt is holding the clay together and binding it. But if you disturb it physically or with a lot of water coming through, you wash out the salt or you remove the salt, and all of a sudden you get a whole bunch of clay that is just not really very solid. So here is a really good demonstration. This is what it can look like when it is sort of looking like it's solid, but this is the lit de clay when it has been disturbed. It flows. So you guys have all heard of quicksand. The lit de clay is a quick clay, and it is found all through the Ottawa area, and especially in places where you are near a waterway like the South Nations River, you are going to have landslides. And back in the 1980s, the Ontario Department of Natural Resources realized that they had a major problem on their hands with respect to the Leda clay and the potential landslides in the area. So what they did was they did a hazard assessment, and they figured out places where people are living. Those are the pink dots where they actually had landslides or whatever. And they were doing an assessment to try and decide what they should be doing about it. So for example, here, Seganburg, near Castleman, they actually decided what they were going to do was reinforce the banks of the river. But at the town site called Lemieux, they decided that they couldn't do that, and they had to move the town. So they did. They took down all the buildings and they moved a few people, and a year after they moved everybody, this happened. And this is the Lemieux landslide. There's about 90 meters of retrogradation from the land, from the riverbank, and over here is where Lemieux stood. So this is a diagram of what actually happened the day of that landslide. You had retrograding. It was, okay, now this is another personal story. Dave and I were moving to Ottawa at that time, and we were house hunting, and it was raining like crazy on the weekend that we were house hunting. And I have a map, a superficial geology map of the Ottawa area in my hand, and I told my my real estate agent I was not going to buy on the Leda clay. So she said, and I said, I'll buy here, but I won't buy here. I'll buy here, but I won't buy here. I'll do this. And she said, like, what's going on here? And I said, I will not buy on the Leda clay. It's as simple as that. So that night, Saturday night, we were debating different housing options, and we had decided on one house. Unbeknownst to us, the next morning we were getting somebody to look at the house, and this person came downstairs in the house and said, of course this is not on Leda clay. And our real estate agent threw up her hands and she said, what do you mean? What is this? And she said, you're talking about Leda clay. They're talking about Leda clay. It's in the news. Like, what's going on? And I said, what happened in the news? And she said, there was a landslide. And I said, now you know why I won't buy on the Leda clay. so this happened the weekend Dave and I were house hunting. And so what happened was that there was so much rain that the flow in the river increased, and it retrograded against the bank. And you know how sometimes you can get something where, like a deck of cards, just slices off? Well, that's what happened. There was so much water coming down, it washed out the salt structures and the clay structures, and it started to give way. And it gave way to the tune of about 90 meters. And it blocked up the South Nation River for 2 or 3 days as the mud cleared and everything else. It was really quite spectacular. Here's another thing to know about the Leda clay and the landslides. This is an air photo taken from 1950, and this is one from 1995 from Beacon Hill. This is a landslide scar. Once the landslide has given way, the soils in here are relatively stable because it can't move anywhere else. But the areas on the edge, not so much so. So, I don't know. They did a pretty good job of not developing much in here, but I don't know if I want to have a house up here. So take a look. You have to look at that sort of thing. So now here, this is, everybody knows about flooding in Ottawa now, right? Now this geoscape poster was done up 15 years ago. Flooding was something that we've always known was an issue. Take a look at the floodplain mapping of Ottawa. What's that? Point Gatineau. We all hear about Point Gatineau. It has been in a risk for flooding from the very beginning. So it's not a big surprise that that's going to happen. Happened in 1974. But one of the things I want you to look at here is that in terms of the flow on the Ottawa River, it comes in 2 peaks. One of them is the melting locally. That's the first one. We start getting melting locally. That's the first peak that we see that happens normally sort of early April. And then we get this huge pulse of the meltwaters coming in from upriver Mattawa areas coming down the river. So we get this huge pulse there. So when we are going to get more moisture in the Ottawa area, which is one of the predictions that's happened with respect to climate change, we are going to get a change in the regime of we're going to get more snow in the winter, we are going to get more rain in the spring. So these 2 peaks, that was 1997, that map. you can imagine what that's going to look like. That particular flow chart will look like for 2017, 2019. This is minor compared to what we've been getting. So this whole idea is that flooding is an issue that you have to contend with. Where do you want to buy? What have you got? You have to look at that. And then I've added this one little bit here, the 100-year flood. How many of you guys have been hearing them say, the 100-year flood, this is just a bunch of, right? A 100-year flood is actually, as opposed to saying it's only going to happen once every 100 years, it actually means that you have a 1% chance of having that kind of flood happen in any year. And what they realize is that for Ottawa, it is now going up in terms of the possibility of this happening. It's no longer a 1% chance. It's going to be much higher than that in any given year. So that makes a big difference with respect to what you're looking at. Here's another thing you might want to consider, especially if you're living in the rural areas of Ottawa and need to have a well for your water supply. It's less of an issue for people who live in the city, but it is an issue for people in the rural areas. The thing about this is you need to know that the clays that we have from the Champlain Sea deposits are actually they are a layer that seal off the ability for water to penetrate into the lower layers. So it's an aquitard rather than an aquifer that can be recharged. There are limited areas in Ottawa where you can actually get recharge into the aquifers. One of the other things is there are certain parts of the city, the west end of the city, you are going to get the exposures of these layers that are the limestones and so on, and shales that we have from the Paleozoics. Remember the 3 types of rocks, the 500 million year old rocks. In the Gatineau area, you've got the billion-year-old rocks. And in the east end, you have these 10,000-year-old rocks. Okay. Water quality varies depending on where your water comes from. So the areas where you have limestone aquifers that you can actually tap into, you're going to get really hard water. If you get into the shales that are associated with those limestones, there's a lot of pyrite in the Billings shale, a name that sounds familiar to people in Ottawa. Billings. Okay, just a little aside. Elkanah Billings was the son of the original Billings homesteader, and he was the first paleontologist at the Geological Survey of Canada, and he was hired in 1857. Just a little aside. Okay, Billings shale is very rich in pyrite, so that you end up with a lot of sulfur and H2S. It's going to be a really rotten smelling, it's safe enough to drink, but it's going to smell terrible. And in the Champlain Sea deposits in the east end of the city, you're going to get a lot, potentially, of things that have a lot of salt tasting to them. And if you have a lot of organic material in it, it could be brown, ugly, and not very pleasant. Because think about it, Mer Bleu, the peat bogs out in that part of the world, you're going to get a lot of organic material out there. Earthquakes. Okay, I told you, earthquakes in the West Coast are an issue. How many of you were around, I don't know, what was it, 4 years ago, 5 years ago now, 6, 7 years ago, when the earthquake hit?
2010.
2010, okay, yeah, okay. All right, earthquakes happen here. Again, the Ottawa area is an area where we have a lot of ancient faults that can reactivate depending on circumstances. Not reactivate in a tectonic sense of subductions and all that kind of stuff. But we do think that the isostatic rebound, that's the rebound of the ground after the glaciers melted, is still going on. And the melt, or the rebound, actually happens along these ancient fault zones. The Gloucester Fault, Hogsback, okay. The whole Ottawa River is actually on the fault zone that goes along with the formation. As I said, rivers, they're on faults. Okay, so Ottawa River's on the Gloucester Fault, and Hogsback is on one of the splays that goes along the Gloucester Fault. It's just known, right? So when we get earthquakes happening, they are not massive earthquakes like you get in the West Coast, but we do get them. And instead of putting this on the Richter scale, which means diddly squat to most people, they just think, ooh, Richter. Okay, what they did was they put on the Geoscape poster for Ottawa, they put an intensity as a person would feel it in the zones. So, and this map goes basically from Lake Ontario up to about Quebec City. That red dot on the top part, that is an intensity where it's really shaking, people can't stand up. that was actually, after Dave's prompting, I looked it up. In 1925, they estimate it was a 6.2 on the Richter scale earthquake that happened in Quebec City. They say it was an estimate because the Richter scale hadn't been developed at that point. But in terms of how you feel it, it depends on how extensive those are. We don't get very many major earthquakes, but we do get enough that that particular earthquake was one, I think it was about 4.5 or something like that.
4.5.
And we felt it all across the city. But one of the things to note is that you are going to feel it differently depending on where you are in the city. Because if you have a house or a building that is built on the limestone bedrock, it's going to shake like this. Everything is going to go together. If you have it built on the lead of clay, it's like standing on a bowl of jelly as it's being shaken. So if you lived in you would have felt that earthquake much more intensely on the east end of the city than you would have on the west end. Am I getting you yet?
Yeah, no.
Do you understand why geology really is important? Okay. Last but not least, everybody talks about the radon issues in Ottawa. So this was a map that was done about the radon possibilities in the region. And you can see the real hot spots are basically in the north, where you have the igneous rocks of the shield, because they are the ones that produce the radon that you're looking at. And you can actually minimize the risk of the radon potential problems by having your home properly ventilated. Now, the problems that a couple of people had a few years ago, I remember it being in the news, was because their house was sealed. So this whole idea of efficiency and making sure that your home is sealed, you have to make sure that you have enough fresh air coming in to make sure that if you do have a radon risk in your area, that you're flushing it out so it's not building up as a potential problem. But again, those are sort of the highlights of the Ottawa area, some of the potentials, some of the risks, some of the problems. And I'm open to questions.